let's just recap what we need to know about proving triangles congruent by side angle side and proving triangles congruent by side side side. For side angle side, we need to find two sides and an included angle of each triangle. That means that the angle needs to be between the two sides that we know. And for side, 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 we need to know all three sides of each triangle. Now we're going to ask ourselves when to use CPCTC in a proof. First of all, remember what CPCTC stands for. It's corresponding parts of congruent triangles are congruent. So we have our CPCTC. When do we use this? Well, we use this after we know the triangles are congruent. This is really important and a key point to solving proofs. So you only use CPCTC after you say that the triangles are congruent. Let's talk about marking a diagram. What would you mark on the picture? It says C is the midpoint of AB. We have A, B, and C on here. What I would mark is that this piece and this piece are congruent. We know that because C is the midpoint, which means that cuts the line in half. So those are the markings that I would add here. What about if it tells me that BD is the angle bisector of angle ABC? Well, an angle bisector tells us that we're cutting the angle in half, and that means that this piece is congruent to this piece. And we would want to mark that on our diagram to help us know what we're looking at. On part C, CD bisects AB. AB is the line that is being cut in half, and so this piece and this piece would be congruent. Notice that AB did not bisect CD, so we want to make sure to only mark the part that we know. That will be an important step as you look at pictures and write proofs as we move forward, to always mark first on the picture what it is you're looking at. Now we're going to look at example 2. Given JM is congruent to NL, and angle JMN is congruent to LNM. So we're going to be writing a proof. If you recall, the very first thing that we write in a proof is the given information. So we're going to start by putting down that JM is congruent to NL, and I'm going to go ahead and mark that on here. So JM is here and NL is here, and I'm marking that on the picture so that I am ready to use that information. The next piece of information was that angle JMN was congruent to angle LNM. JMN is this angle, and LNM is this angle, and I have marked those on there. Now the reason is given. Just to keep my proof nice and tidy, I like to draw a little line here. What we're trying to prove is that the two triangles are congruent. The next thing that we need to mark is what we can see in the picture that we know to be true. And I'm going to say that MN is congruent to NM. MN is congruent to NM. And this is the reflexive property. I like to think of this one like looking in the mirror and seeing my reflection, reflection, and we're the same exact person in the mirror and out of the mirror. And this line, MN, is part of the top triangle and part of the bottom triangle, but it is the exact same line. So that is the reflexive property. Now I want to ask myself, do I have enough information to prove what I came to prove? And which is this. And I believe that I do. I have a side and an angle and a side and a side and an angle and a side. So I can now say that triangle JMN is congruent to triangle LNM. And I can say that this is the side angle side theorem. Short and sweet proof. Let's do another one. Again, we're going to start off with what was given to us. So I'm going to say that HI is congruent to GJ. HI is congruent to GJ. And HI is parallel to GJ. So I'm going to mark that as well. And remember, parallel is marked with a little arrow on the line. So those are parallel. And that is true because it was given. So my reason is that it was given. I'm going to have to use the idea that they probably told me these are parallel for a reason to be able to look and say that this angle and this angle are congruent because these lines are parallel and those are alternate interior angles. So I'm going to state that angle IHJ is congruent to angle GJH, and my reason is alternate interior angles theorem. The next thing that I see is that HJ is congruent to itself. So HJ is congruent to JH. Again, this is that whole looking in the mirror and seeing yourself thing, that reflexive property. Do I have enough information yet to prove that these are congruent? Well, I see that I have side and an angle and a side, and a side and an angle and a side. So I am good to go, and I can say that triangle GJH is congruent to triangle IHJ, and my reason is the side angle side theorem. It's time for you to pause the video, do the try it, and then come back and check. If you are totally lost, you can go ahead and follow me through, but I would really encourage you to at least pause your video, look at the picture, fill in the parts that you can, and then come back and check your answer. So V is the midpoint of both lines. I'm going to put that there. We're going to mark that information that we gained from that, but we actually still have to state that information. So I'm going to go ahead and say that WV is congruent to ZV, and XV is congruent to YV. And my reason here is definition of a midpoint. And you could have written those as two separate steps. Choose to write them as one. The next thing that I need to do is determine if there is a way to find either an angle that would be included or the third side. I don't see a way to get that third side, but I do see a way to get that angle. Looking right here, we see that this is a vertical angle. We cannot call that angle V because we wouldn't know which piece we were talking about if we called it angle V. So make sure you use 3 letters. And I'm going to say that angle ZVY is congruent to angle WVX. Angle WVX. And my reason is that those are vertical angles. Notice that we are going back and using things that we learned in previous units. That is why I've said do not get rid of your packets, keep them handy. You may need to go back and look up these theorems. So this is the vertical angles theorem. Now I have enough information because I have side, angle, side, and side, angle, side. So I can state that triangle WXV is congruent to triangle ZYV, and that is because of side, angle, side theorem.